Hi everyone, how are you? I hope you all are fine. In this video, we will start a new chapter of trigonometry. First, we will start with the easy and well-known theorem. It's Pythagorean theorem. If we have a right triangle, okay, and all our studying in this video will be about the right triangle. If we are given the three length of the right triangle, 3, 4, and 5. Okay, the longest side, which is opposite to the 90, we call this its hypotenuse. Its hypotenuse. Okay. 3 and 4 are the two legs of the right angle. Now you will find the relation between them. You will find out that if you squared 3, this will be 9, 4 squared is 16, and 5 squared is 25. Can you see that if we added 9 plus 16, the two legs would be 25? The person that discovered this relation is Pythagorean, so we called the theorem by after his name. It's Pythagorean's theorem. Okay, now for some examples, if we have two givens, for example this is 6 and this is 8, we need to find out what's the hypotenuse. We use the solution square root. We need to find out the biggest side, so we need the biggest side, the biggest answer, so we add 8 squared with 6 squared and take the square root. So square root of 8 squared plus 6 squared, so the answer is 10. Okay, let's try a different one. If we have a triangle, this is the 90 degrees, so can you see that now the hypotenuse is here? Okay, if I gave you, for example, this is 5 and this is 12, we need to find the hypotenuse. We say that to find the hypotenuse, we add. So we add 12 squared and 5 squared. By the calculator, this would be 13, okay? But if the example is giving you the hypotenuse, for example, this is 5 and this is 3, and one of the two legs is missing. For example, this is x. How to find this x? Okay, can you note that you have the hypotenuse here? Okay, so we write on the calculator root 5 squared and 3 squared, but instead of adding will give you an answer greater than the hypotenuse. It's not accepted, so we subtract. If you have the hypotenuse, we subtract. If you miss the hypotenuse, we add. Okay, now we subtract. By the calculator, this will be root of 16, which is 4. Now the missing is 4. So can you try this with yourself? Pause the video and try to find out the answer. This is 10 and this is 8. This is unknown. The answer will be square root. It's minus because we have the hypotenuse. So this is 10 squared minus 8 squared. The answer will be 6. Okay. We can say that the side which is opposite to the 90, it's always the hypotenuse, okay? So if this is C, now C is the hypotenuse. What about A and B, the two legs of the right triangle? Okay, if we have angle theta, can you see that this is opposite to theta? And this one is adjacent to theta. So the hypotenuse, it doesn't change, but A is opposite to theta, B is adjacent to theta. So what if we have angle phi, for example, here? Now B is opposite to phi, A is adjacent to phi. So the position changes the name of the third or the second side. Example, if we have a triangle here and we have angle here, for example, this angle is x, okay? So this is the hypotenuse, and this side is opposite, and this side is adjacent, okay? A different one, this angle is y, and this is the hypotenuse, so this is opposite, and this is adjacent, okay? We have a well-known ratio between the sides, which is ka tua. For example, if we have this angle x, and this is, for example, 6, and this is 8 and 10, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan the opposite over adjacent, okay? So ka toa. So if I asked you to find out sine x, for example, you should look at this sine opposite over hypotenuse. Where are the opposite and the hypotenuse? This x, so the opposite is 6, the adjacent is 8, and this is always the hypotenuse. So now to take opposite over hypotenuse, you should take 6 over 8, okay? Cosine x, cosine adjacent over hypotenuse. You have marked the adjacent, which is 8 over, sorry, this is 10, sorry guys, this is 10, okay, 8 over 10. The last one is tan x. Tan x, it's opposite over adjacent. The opposite is 6, adjacent is 8. So katoa, okay? We have also, if you change this, if you flip this, each one of the three ratios, each one has an inverse. The inverse of the sine is cosec x, and it's 10 over 6. The inverse of cosine is sec x, and it's 10 over 8. Cotan x is the inverse of tan, and it's 8 over 6. Okay, let's take a different example to make sure that you understand. If you if there's a problem with this, if you are lost in this area, I can give you another example to make sure that you understand. Let's try this from the beginning. If we have here angle x, and this is 5, 13, and 12. Remember the relations? So ka tua. Okay, sine, this is opposite, this is adjacent, and the 90 is always opposite to the hypotenuse, okay? Sine x opposite over hypotenuse, so 5 over 13, and cosec x is 13 over 5. Cosine x is adjacent, which is 12 over 13. Sec x is 13 over 12. Tan x is opposite over adjacent, which is 5 over 12. So cotan x is 12 over 5. Okay, now let's move to problems to solve the triangle. Okay, we have two types of problems. The first one is missing side. The second one is missing angles or angle. Okay, if we have a triangle for this example, if we have this 30 and the opposite is unknown x and the hypotenuse is, for example, 8. Okay, you need to know which ratio to choose, okay, or to use. Let's remember, okay, we have the opposite, we have the hypotenuse. They are both involved in the problem. So we will use opposite with hypotenuse, it means sine. So we will write sine 30, and this step is more important than the solution. Sine 30 should be x, which is the opposite, over 8. Now how to find the x? You multiply, cross multiply 8 multiplied by sine 30, and this is one part, you cannot divide it to be 8 multiplied 30. No, it's 8 multiplied sine 30. You can use the calculator to find the answer. 8 multiplied sine 30 and close the brackets, the parentheses. It's 4, so the answer is 4. Okay, do you need a different example? Of course. Let's try this. For example, this is 6 and this is unknown and the angle is 40. Okay, now what do you have here and what's required? You have the opposite and you need the adjacent. Opposite and adjacent, use the tan. So write this tan 40 should be 6 over x. How to find out the answer of x? You cross multiply, you change x with tan 40, so x will be 6 over tan 40. Send this and give this back in the denominator. Okay, by the calculator, be careful in using the calculator. This is 6 over tan 40 and close the bracket. This will be 7.2. okay, so this is about missing side. What about missing angles? We need to find out the measure of this angle, and we have the opposite, which is, for example, 8, and the hypotenuse, which is, or let's try a different one. This is 8, the adjacent is 8, and the hypotenuse, for example, is 16, for example. Now what do you have in the problem? You have the adjacent, you have the hypotenuse. Adjacent and the hypotenuse, you will use cosine, so you should write cosine x, which is unknown, is 8 over 16. To find out this, it's very easy in the calculator. You, instead of write cosine x, the angle is missing, so we will write shift cosine x, shift cosine, which is here, shift cosine, and write the bracket, shift cosine 8 over 16, then press equal. The answer is 60. So it's easier because you use the calculator in one step to find out the answer, but by using shift, not the cosine, shift cosine. A different one here, x, and this is 8, which is double this, for example. So what do you have here? You have the opposite, you have the adjacent to this angle, okay, and we don't need the hypotenuse. Okay, adjacent with opposite, the angle is missing, so we use shift. So it's shift tan 8/4. Shift tan 8/4. It's 63.4. So this is everything about how to find missing side and missing angle. Okay. Again, if the hypotenuse is missing, we add. If the hypotenuse is given, here we subtract. Okay. Remember this is SOHCAHTOA. Sine is 6/, if sine is 6/10, so the cosec is the opposite, 10/6. Cosec is the inverse of sec, tan is the inverse of cotan. And we have 4 examples of missing side and missing angle. Okay. If you are giving that sine and angle equals 3/5, can you find out what's tan of the same angle? You can think, pause the video to think, then replay it. Okay. You know that sine, this is the opposite, and this is the hypotenuse. So if you draw a triangle, and this is the x or theta, the opposite is 3, the hypotenuse is 5. Can you find this? Yes, root 5 squared minus 3 squared, which is 4. Now you have the adjacent. Tan is opposite over adjacent. You have the opposite and adjacent, 3/4. If I told you that you have a terminal side of a triangle and the point, for example, 5 and 8, okay, you'll be given an example, a point on terminal side x and y, it's adjacent. The x will be always the adjacent and y will be always the opposite. So for example, if I give you this point 3 and 4, you should know that this is the adjacent and this is the opposite. So if I ask you to do about sine, cosine, or tan, you should answer me quickly. So tan is opposite 4/adjacent 3. But you should know that if the opposite is 4 and the adjacent is 3, can you figure out the hypotenuse, which is 5? 3 squared plus 4 squared, which is 5. Now you have the hypotenuse is 5. So sine is 4/5, cosine is 3/5. A different example, -8, or example 5 and 12. You need the hypotenuse first, root 5 squared plus 12 squared, it's 13. Now you have the adjacent, the opposite, it's always the opposite here and adjacent here. Now you can find sine x, it's 12/13. Cosec x, it's 13/12, and so on. Okay, thank you, and I hope this video is clear. You can try to solve the assignment, and if you have any problem, you can come back to me and I will re-explain to you anything.